Hello, pre-calculus. Today we are doing section 2425, and really it's more just 24 or 25, sorry. Not really much in 24. Doesn't really matter, just worksheets. Let's see. We are learning about possible rational roots. So to learn about possible rational roots, you need to remember what rational means. Rational has the word ratio in it, and rational numbers are real numbers that can be written as a fraction. You probably learned about these like a long time ago in maybe algebra 1 or something. So for it to be written as a fraction, obviously a whole number could be written as the fraction, like the number 5 could be written as 10 over 2. Anything it doesn't include it if it's over 1. Like I could do 5 over 1. That's not what I mean by writing it as a fraction. 10 over 2 we can write as a fraction. Decimals that end like 0.25, we should know that's 1/4, so that can be written as a fraction. And decimals that repeat, like 0.333 and so on, that is the fraction 1/3. So those are real numbers. Those are real rational numbers. And then we've got irrational numbers, which maybe you can guess it, numbers you cannot write as a fraction. They would be decimals that go on forever, but do not repeat. You might know that pi is an irrational number. E is an irrational number. And the square root of any non-perfect square would be irrationals, like square root of 2. So today we're talking about possible rational roots. So today we're not going to be finding any information out about roots that are not rational. So roots like irrational or imaginary. So this will not tell us anything about those kind of roots. But we will learn about rational roots. When we have a polynomial, we're going to call the constant term, which is that last term, we're going to call it p. Actually, we're going to call the factors, I should say, the factors of that last term, we're going to call p. And then the factors of the leading coefficient, we're going to call those q. And then to find all possible rational roots for a polynomial, we list all combinations of plus minus p over q. For example, we've got f of x. The p numbers would be anything that can be factored out of 5. So we've got the number 1 and we've got the number 5. However, if I multiply 1 and 5, I can get 5. If I multiply -1 and -5, I could also get 5. So we need to include the positive and the negative for every single choice. Now our q numbers, we have 42 to work with. So plus minus 1, plus minus 2, plus minus 3, plus minus not 4, not 5, but 6. 6 goes in 7 times. 3 goes in 14 times. 2 goes in 21 times. And 1 goes in 42 times. So those would all be the factors of q. Now to find p over q, we are going to take all of our p's and put them over each Q. We're going to find every single combination. So I'm going to have P over Q. I will start with the P that is plus minus 1. And I'm going to put plus minus 1 over every single Q. So we will have plus minus, if I do 1 over 1, then I get 1. Plus minus 1 over 2. Plus minus 1 over 3. Plus minus 1 over 6. Plus minus 1 over 7. Plus minus 1 over 14. Plus minus 1 over 21. And plus minus 1 over 42. Those are all the ones. Now I have to do the same thing with the 5s. So plus minus, I do 5 over 1. Plus minus 5 over 2. 5 over 3. 5 over 6. 5 sevenths. 5 fourteenths. 5 21s. And 5 42s. So what we have done here is we've taken every single rational number that ever existed, which there are infinite amount of them, and we have said that the rational roots, the zeros that work in this polynomial, are now limited to this small amount. How many we got here? So we've got 32 different possibilities. The degree of this polynomial is 3, which means we have at most 3 zeros. Well, we have 3 zeros, but most 3 different zeros, I should say, because we could have 3 of all the same number. And if they are rational, because they could be irrational or imaginary, if they are rational, they will be contained in here. So what we are doing is we are just going to find all the possible rational zeros that you could have. Now, back in the day before calculators, and sometimes if you go to a course that doesn't allow you to use a calculator, possibly in college, you might have to do this next thing by hand. So I just want to show you what we had to do, and hopefully that'll make you appreciate technology. Back in the day, we would have to take this list, and I say we. I had a graphing calculator in high school, so back in the day before me, they had to take this list, and I'm pretty sure I had to do this in college without a calculator. We weren't allowed to use it at Miami. So anyway, we had to take this list, and we had to start wherever we wanted, usually start with the ones, and we had to say, okay, is 1 a 0 of this polynomial? So this is a guess. Is 1 a 0 of this polynomial? I'm going to do my synthetic division. So no, there is a remainder, so 1 is not a 0. So I cross that one off the list. So my next one I'm going to try is -1, a 0. And yes, -1 is a 0. So from there, I would take 42x squared minus 41x plus 5, and I would either factor what's left, or I would do quadratic formula if it's not factorable. Okay, but you can imagine with higher powers, like the next one is a 4, or if there were more choices, or if I didn't pick, like maybe the choice is, I don't know, 5/21, and I had to go through every single one of these before I figured it out. That would be a big pain. So we should be very thankful that we have technology. I'm going to show you how we're going to actually do today's lesson. I am going to leave this up because I will still need this. This is what I'm going to do next anyway. I'm just going to find the -1 a different way. And I'm just going to write a note on here before I go to the next screen. We're going to find this with technology, with our graphing calculator. So on your previous lessons, the quiz that you just took, I gave you the first few zeros or the first few factors. This time I've given you none of the factors. So we're kind of starting this one with no help. So what we're going to do is we're going to go to our calculator and we're going to graph the equation on the calculator. Okay, we're going to graph it on the calculator. Then we're going to find a 0 using either second trace 0, or you can use second trace value. And I'll show you both of those today. Okay, so I'm going to go to my graphing calculator. I have it here, and I didn't want to take a lot of the time on the video, so I went ahead and just plugged all of the equations that we're going to graph in this video. I just already plugged them in. So I'm just only turning on the one that we're graphing right now. So I'm going to hit graph. And I think I want to change my window so I can see it a little bit better. So I'm going to go to window, and I think my X's, I want to look from like -5 to 5. Just want to kind of zoom in a little bit on those X's. Okay, so now I can see a little bit better. So as soon as I see this, I'm going to pretend that I don't know -1 is a 0. As soon as I see this, I'm going to go from left to right, and I'm going to notice this kind of looks like it's passing through -1. So I'm going to go second trace, and you can either use value or 0. I'm going to use value this time because I think I know that it's passing through -1. So I hit value, and it says, what value would you like? And I say, when X is -1, so I type in -1, what does the ordered pair equal, or what does Y equal? So I hit enter, and it tells me that Y equals 0. So if Y equals 0, this is a 0. So we found X equals -1. My next step would be to come back over to my notes or my assignment and use synthetic division to take out -1 because I just found that that is a 0 from my calculator rather than from this list. So our next step after we find this is to divide out the 0 by synthetic or long division, depending on if it is a fraction or if it is a whole number. Okay, we're going to repeat this. Until you have a quadratic left. And then when we have a quadratic left, we will either factor or quadratic formula or complete the square. So if you have a cubic like we had here, we would only have to find 1 0 with the calculator. And then I've got my 42x squared minus 41x plus 5. So at this point, I can either do quadratic formula or I can factor. And I'm going to try factoring. That doesn't mean it is factorable. I'm going to try factoring because I know that 5 and 1 have to be those last two numbers to give me a 5. This is a minus and then a plus, so it has to be a minus and a minus. And 42 is normally 6 and 7, but there are other factors it could be. But I'd just like to try the easy ones first. Okay, I'm going to check it by saying that's minus 6x, and this is minus 35x. Does that equal minus 41? It does. So I just happened to guess correctly the very first time. So I factored it. I'm going to set each factor equal to 0. So we get 6x equals 5. So x is 5 over 6. And that is in our p over q values, 5 over 6. And then 7x minus 1 equals 0. So 7x equals 1, x equals 1/7. And 1/7 is also in our p over q values. I believe this one says to write it in factored form. Let me double check here. Yeah, so this assignment, we're going to write the polynomial in factored form. And of course, I've used up so much space, I'm going to have to squeeze it in here. I'll put it in pink. So my factored form of this polynomial, you're going to follow the format of what we did section 2.3 day 2 when you had to type it in. We're going to look at the order of our zeros, which our zeros are -1 and then 1/7. Oops, my stylus turned off. And then 5 over 6. So that's the order from left to right of our zeros. So I'm going to put our factors in that exact same order. So the first factor for -1 is going to be x plus 1. Then 1/7 is 7x minus 1. There's my factor right there. And then we've got 6x minus 5. Okay. Question B. We're going to start with the p over q first. I'm going to zoom in because I feel like I need more space. I'll change my writing. Here we go. So we're going to start with our p and our q. So 9, that's going to give me plus minus 1, plus minus 3, and plus minus 9. My q is just 1, so plus minus 1. So we go to do plus minus p over q. And we're going to get plus minus 1 over 1, plus minus 3 over 1, and plus minus 9 over 1. So this one, we only have 6 options for rational solutions. The other one, we had 32 options. This one, we have only 6, so there's like a lot less. But we're still going to use our calculator. So we're going to go to our calculator, and the first thing that we're going to do is we're going to type in that equation, which I've already done to save a little bit of time on the video. Of course, if you're following along, you could just pause the video. And then to fix my screen, because I messed around with the window, I just hit zoom 6, and that will always go back to that standard screen. And then I'm going to go from left to right. If I want to look at it closer, maybe I'll change my window to go from, I don't know, -7 to 2 for my x's, just so I can see it a little bit better. -7. Oopsies. I forgot if I use my keyboard on this, it doesn't like it. -7 to 2. There we go. So now I can see a little bit better. I'm going to start with this first left 0, and I'm going to see if I can find it. We're going to go second, trace, and I'm going to pick 0, number 2. And it's going to ask me for a left bound. So something to the left. So this is like -1, -2, -3, -4, -5. So maybe I'll pick -6. And I just type that in. -6, enter. Oops. And it puts up that line for me. Now the right boundary, how about -4? -4, enter. And now it puts up that right boundary. So I'm telling the calculator, look in between these lines for something that makes y 0. It does ask for a guess, and that's because sometimes there could be multiple ones in here, and we just want to make sure that the calculator knows which one you're talking about. So my guess is going to be -5. And I get a horrible looking decimal. I wonder if this is an irrational number, because all the rationals I've listed. All my rational choices are -1, -3, -9, and this is not any of those. So I'm going to hold off on that one. And I'm going to go and look to the right. And the next one, it actually looks like it might be at -3. So I'm going to do second trace, 1. So I picked value, and then I'm going to do -3 and see if that really is a 0. And it is. So I know that my first one that I'm going to take out of this polynomial is -3. So we can use synthetic division because it is not a fraction. If it is a fraction, we're going to have to do long division. And the -3 comes out. That takes our degree of 4 down to this one here now has a degree of 3. And because it's not a degree of 2, that means I should be able to find another 0 from this picture. So what you have to think about now is multiplicity. We see that at -3, this graph goes up and it bounces at -3. It does not go through the graph, it bounces. It's got that quadratic kind of look to it. So I'm thinking that this is probably -3 again. So there's only one way to find out. Well, there's not only one way, but the one way that I'm going to use to find out is I'm going to take -3 and I'm going to take it out of what was left over from the previous division. And I have a remainder of 0, so that means yes, -3 is actually in there twice. So at this point, I now have a degree of 2. So since I have a degree of 2, I can solve it a different way. And I'm going to have to, because you saw the answer when we tried to find the other 0, it was not going to be a nice answer. So I try to factor this. It's not factorable. Let's use quadratic formula. X equals opposite b plus or minus square root b squared minus 4ac all over 2a. So get -5 plus or minus square root 21 over 2. So I have it. I've got 2 irrational answers for my last 2 zeros. So for our zeros, let me list our zeros over here. We had, let's see, from left to right, the first one is going to be this irrational one. Sorry. There we go. So -5 plus or minus square root 21 over 2. Oh, not plus or minus, I'm sorry. Since we are using the smaller one, it's going to be the minus. And then we'll have -3, but that happens twice. I don't need to write it twice. I'll put times 2 there. And then we have negative 5 plus square root 21 over 2. So we've got our zeros from left to right. There were 3 zeros, and there were 3 places where it touched the x-axis. This one in the middle bounces, so technically there's 4, but 3 different ones. So to write these as factors, x equals, I feel like I want to separate this, negative 5 halves minus square root 21 over 2. I just feel like that would be easier. And then x equals negative 3, and then x equals negative 5 halves plus square root 21 over 2. To write these as factors, we're going to have to add 5 halves to both sides, add square root 21 over 2 to both sides. This factor here is going to be x, and then we're going to add the 3 plus 3. And then this factor over here is going to be x, and then we're going to add 5 halves. Then we're going to subtract square root 21 over 2. So hopefully, fingers crossed, this is... Nope, I've made a mistake because I forgot about this here. So if there is a multiplicity of 2, I need to make sure I have my squared there. Now let me repeat that. Hopefully, this is the factored form. And on Monday or Tuesday, no, Friday or Monday, next time I see you all, we're going to go over how we can find out that we did it correct. But that's going to be next time. We're going to do that in class together. One thing that you can kind of just double check, just, for a moment, is that if I were going to multiply f of x, if I were going to multiply all those factors back together, my first terms would all multiply together for the first term up here, x to the fourth. So I have an x here, I've got an x squared for this one, and an x here. So that would equal x to the fourth. So there is maybe a hint that we are on the right track. All right, the last question. Now, I don't know why I don't make this paper, just spread it out more. I remember this one always takes up so much space for the P and Q part. So if you have the ability of, zooming way far in, go ahead and do that. Or I had some extra space above, which I'll probably use. Or you could just, do what you need to do to make it fit. So let's see, P over Q. My p-values involve 120, plus minus 1, plus minus 2, 3, 4. And while I'm doing this, I think I'm going to kind of like do 1 times 120 and have that like 120 here, so I don't forget any. 2 times 60. 3 times 40, 4 times 30, 5 goes into it, 24 times, 6 goes in there, 20 times, 7 does not. 8 does 15 times. I don't know. I didn't look at this ahead of time, so I don't know if I'm going to run out of space or not. Does 9 go into 120? I do not think 9 does. No, 9 does not, but 10 does. And that goes in 12 times. So I just made it in space here. All right, now we do our Q's. And that is a 12. So plus minus 1. If my marker works, there we go. Plus minus 2, plus minus 3, plus minus 4, plus minus 6, plus minus 12. All right, so now what we have to do is we have to write every single possibility. There's a lot. So I promise you, I will not write them all, and I'll never give you one this insane to do. But I'm going to start it because I want to show you a couple things. Okay, so I'm going to start with the ones, and I'm going to put the ones over all of the q's. So I get plus minus 1 over 1, so 1. Then I get plus minus 1 over 2. Then I get 1/3, 1/4, 1/5, 1/6, and 1/12. Okay, and then I'm going to start my 2's. I'm going to put 2 over 1, which is 2. Then I'm going to put 2 over 2. But 2 over 2 is already 1, and we've already listed it. So we're not going to repeat any that reduce to something we already have. So now I'm going to put 2 over 3. I do not have 2 over 3 yet. I'm going to put 2 over 4, except 2 over 4 is a half, and I already have that one. So next is 2 over 6. Well, that is 1/3, and I already have that one. And then I've got 2 over 12, and that is 1/6, and I already have that one. So for 2's, that's all I was able to find. Let's see. How about 3's? So plus minus 3 over 1, plus minus 3 over 2. That's a new one. Plus minus 3 over 3 is 1, so I don't have to write that one. 3 over 4 is new. Plus minus 3 over 6, that's 1/2. I already have that. And 3 over 12, that's 1/4, and I already have that. So you see, as we go on, we a lot of these end up repeating when they've got, if they're all evens or something like that, they'll end up repeating. So you won't have as many combinations to write. You definitely don't want to write repeats in here. So I'll just do a few more. Plus minus 4 over 1, and then plus minus 4 over 2. Well, that's 2, and I already wrote that one. Plus minus 4 over 3. That one's new. 4 over 4 is 1. 4 over 6 is 2/3. We have that one. And 4 over 12 is 1/3, and we have that one. So I'm not going to finish this list. I wanted to give you this list so you have an idea of the different combinations and how a lot of them will reduce. So now let's finish this question. So the next thing you would do after you list all of these is just go to your calculator, go back to my y equals. I'm going to turn off question B, and I'm going to go where you're going to go plug it in, or I'm going to just turn it on because I've already plugged it in. I'm going to hit Zoom 6 to fix my window, and I have a graph. All right, and I'm looking very carefully, and unfortunately, none of these are integers. Kind of want to zoom in, so let's go from, how about -4 to +4 on my x's. It does look like this one is exactly in the middle. So you could either try value, or we can do 0. I'm going to do 0 again. If you want to do value, that's totally fine as well. I'm going to do second trace, and I'm going to try 0. And I'm going to try to find this one. So I need to pick something to the left. 1 to -3, enter. And then the line comes up, and then something to the right is 2, -2. And then guess, I'm guessing it's -2.5. And when I hit guess, it tells me, yes, it is -2.5. That is the 0. You will notice in our list, we don't have any 2.5. Well, we didn't even get that far in the list. That would be if I had done the 5s. Maybe I should do the 5s real fast. What color have I not used? Red. Let's do the 5s real fast. Let's see, 5 over 1, 5 over 2, 5 over 3, 5/4, 5/6, 5/12. There you go. Did my 5s. 2.5 is the same thing as 5/2, and that one does show up in our list. And we are doing rational roots, so we're talking about fractions. So I have x equals negative 5/2. This kind is a fraction. You do not use synthetic division. It will cause you problems if you use synthetic division. You are supposed to multiply both sides by 2. 2x equals negative 5. Then add the 5. 2x plus 5 equals 0. And now we use long division. Now, you will notice our degree is 3, sorry. Degree is 3. So that tells me that I only have to take out one factor or 1 0, and then I can do quadratic formula or factoring with the rest of it. So yes, I have to do long division, but I only have to do it once. So let's do it. You see how all this stuff we've been learning is put together in this section here. 2x goes into 12x cubed. If you can't do that in your head, you go off to the side. 12x cubed over 2x. That gives me 6x squared. I distribute that. 12x cubed plus 30x squared. Draw the line. Change the signs. And I get negative 50x squared. Bring it on down. Repeat the process. Negative 2x into negative 50x squared. So it's going to give me minus 25x. Distribute. Negative 50x squared minus 125x. Draw the line, change the signs. And 25 plus 23, 48. I just double check my math real fast before I go on. Okay, I did it right, good. All right, and then finally I'm going to go 2x into 48x, which is 24. I'm going to multiply that out. I'm going to get 48x. 24 times 5 is, oh, we just had that, 120. Oh, yeah, and it should be because, because it has to cancel out and give us 0. All right, so now I have a quadratic left. I have 6x squared minus 25x plus 24. I'm going to see if I can factor this. I'm not sure if it's factorable. And if it's not, then we'll use quadratic formula. But if it is, I just saved myself some time. So this is total guess and check here. I am not looking at the answer ahead of time. The last time I did this problem was like last year. So 24, that could be 6 and 4. So if I try 6 and 4 here, oh, I know, never mind. I know I can't be that because 6 and 2 can't be together, or there would have been a GCF. So maybe I'll try 8 and 3. Let's see. That'll be negative 16x, and that'll be minus 9x. Does that equal? It does equal negative 25x. So I factored it correctly. Yay. So now we do 2x minus 3 equals 0. 3x minus 8 equals 0. We're going to find those zeros. And I'm going to put them in order. So here's my zeros. The first one was negative 5/2. And then the next one will be, what is this? 2 2/3. And this one is 1 1/2. So 3/2. And then 8/3. And all of these answers should be in P over Q. You won't see 8/3 because I stopped before I got to the eighths. But again, I'm not going to give you any that are just that incredibly long and tiresome. So now we're going to write our factored form. Was this f of x? It was h of x. H of x. And I have to have each of these as factors, which we have somewhere in our work already. 2x plus 5. And then we have 2x minus 3. And then 3x minus 8. Just a quick little check here. If I did multiply together 2x, 2x, and 3x, that would be 12x to the third. And we go and we look at that first term in the original question, 12x to the third. That kind of looks good. And you could check the 120 as well. You could multiply 5, -3, and -8, and it should equal that 120. All right, so that's it. You will bring your completed assignment to class. And we're going to actually do something in class together with it. So it is very important that you have this done on time. I've been very lenient about this entire year. So I'm asking, do this assignment on time so that we can do the next step together. Have a wonderful day. See ya.